Okay, we're picking up with Unit 2, Lesson 11. We've just finished Example 2, and before we get to Example 3, we're going to look at a key concept on oblique asymptotes. So, we have a polynomial function, a rational function that's a of x divided by b of x. A and b are polynomial functions with no common factors other than 1, and b of x can't equal 0. Then the function has an oblique asymptote if the degree of a minus the degree of b equals 1. So if you do the top power, the highest power on the top minus the highest power on the bottom, and you get 1, then there's an oblique asymptote. So as an example, if we see the function highest power on the top, x to the fourth, highest power on the bottom, x to the third, there's going to be an oblique asymptote. The oblique asymptote is x plus 3. The way you find that is you have to do the actual division and divide out the factor from this problem. And I'll definitely do that on the board in class. But basically what you want to do, let me see if I can do some long division or for this problem. So we have x to the fourth plus 3, wow, can't make rounded numbers today, 3x to the third, and into that I am dividing, wow, that's really bad, that's not even close to a straight line, x cubed minus 1. So to do your long division, you want to ask yourself, what do I multiply by x cubed to get x to the fourth? And the answer would be x. If you multiply x times x cubed, you get x to the fourth. If you multiply x times negative 1, you get a negative 1, which I will put over here. Then we're going to, wow, whoops, not even close to straight lines, sorry. We're going to subtract now. Subtracting flips the signs of each term. We're going to subtract that. The 3x to the third comes down. And the 1 comes down. Technically, there's also a 0x squared and a 0x in there. Then you want to ask yourself, what do I multiply by x cubed to get 3x cubed? And the answer is positive 3. So you multiply 3 times that. You bring the 3 down. That cancels when we subtract. Wow, not a straight line at all. Anyway, that goes away. If I put on the 0x squared, you'd see how all this other stuff works out. But basically, this is how, right here, that's how they come up with x plus 3 as the oblique asymptote. You have to do the division of the top divided by the bottom factor and see what factor you have left over, and that'll be your oblique asymptote. So oblique asymptote is basically a slanted asymptote. It's a diagonal asymptote. So you can see over here, this diagonal line, that's the line x plus 3, y equals x plus 3. So it's a little bit more work to find an oblique asymptote, but I don't think the process itself is difficult because you already know how to do division. You can obviously identify highest power in each side, and you figure out that the top power is 1 power higher than the bottom power. So let's look at an example where we use an oblique asymptote. So example 3 says we have a function x squared over x plus 1. And obviously the top power, the degree of the top is 2. The degree of the denominator is 1. The top is 1 power higher than the bottom, so there's going to be an oblique asymptote. We want to find our vertical asymptote, which is when the denominator equals 0, and that would be when x is negative 1. So we're going to have a vertical asymptote at x equals negative 1. Let me come over to my grapher and delete all this information. X equals negative 1. We know we have that. Let me try to zoom back in here. Let's go square grid. Let's go negative 10. to 10, negative 10 to 10. Okay, so we've got a vertical asymptote at x equals negative 1. And what I'm going to do next is figure out my slant asymptote. So I'm going to do some division. I'm dividing x plus 1 into x squared. So I'm going to call this, just so I can write out everything, x squared plus 0x plus 0, just to make sure I get everything written the technical way that you're supposed to do long division. Still can't draw straight lines with my mouse though. X plus 1 is our factor that we're dividing in. So I ask myself, what do I multiply by x to get x squared? And the answer is x. X times x gives me x squared. X times 1 gives me 1x. We're going to subtract. That cancels. That would be negative 1x plus 0. X times what gives me negative 1x? That would be negative 1. So if I multiply that, negative 1 times x gives me negative 1x. Negative 1 times 1 gives me negative 1. We're going to subtract now, so we flip our signs. We cancel, we're left with 1, whatever. This is our factor right here, x minus 1. That's going to be our slant asymptote, or our oblique asymptote. So they want you to, step 1, find your zeros. So finding your zeros is finding when the numerator is going to equal 0. So we have x squared equals 0. We're going to take the square root of each side. You get x is 0. There's a 0 at x equals 0. They're going to say step 2, find your asymptotes. So our vertical asymptote, like we already said, was negative 1. The degree of the numerator is greater than the degree of the denominator, so there is no horizontal asymptote. But the difference between those degrees is 1, so there is the oblique asymptote. And that's the thing that we already found. So when we did that division, just like what I showed before, you're going to come up with x minus 1. The equation of the asymptote is the quotient excluding and the remainder. So we're not worrying about the remainder, we're excluding the remainder. So our oblique asymptote is the line x minus 1, which is what I had shown on the previous slide. So I can come over here. I'm going to say y equals x minus 1. So that's our oblique asymptote. So just from looking at this, you can see how the graph is divided into 4 sections. We have this section up here, then this section, and then this bottom section down here. It's a big X that's our graph is split up into. And whenever you have a function like this, it's going to occupy, your graph is going to occupy 2 of the opposite sections. So it'll either be the upper left and the bottom right, or it would be the upper right and the bottom left. And my suspicion is that it's going to be in like something like this, the bottom right, and then the bottom left and the upper right. That's my suspicion, but I'm not really sure yet. So what we're going to do next is we're going to make our table of values. So our vertical asymptote was x equals negative 1. We're going to pick some values around x equals negative 1. So let's go with negative 5, negative 3, negative 1.5, negative 1.25. I want to get pretty close to my asymptote so I can make sure I know exactly what's going on. Then I might pick negative 0.75 on the other side of the asymptote, negative 0.5. Maybe I'll pick 0. 0 is always a nice easy number to throw in. 2, 4, whatever. Okay, so my function, if I come back over here, it was, oh, I remember what it was now. It was x squared divided by x plus 1. So we're going to take our different x values, and I don't want to look at that graph because that showed the answer. We're going to plug in our different values for our number. I need my parentheses actually. Oops, not in there. I need it like that. Okay, so my first value I'm plugging in is -5. Okay, so when we get that, it's -6.25. So up here, -6.25. Then we're going to do -3, and we get -4.5. Then we're doing -1.5, and our answer is, there's no way it's -4.5 again. I need to pick another value in between there. Let me throw in -2 and see what that is. -4. That's going to be helpful for us. Did I do that? I think I did that wrong. Oh, sorry. It's supposed to be down here. There we go. Okay, -1.25 gives us -6.25 again. You can see the pattern now is starting to form like that curved line. So now we're going to jump over to the other side. We're going to put in -0.75. We get 2.25. -0.5. We get 0.5. We're going to throw in 0. We better get 0. I'll just show you just to make sure. 0, 0. What do you know? Okay, we're going to plug in 2. And we get 1.3 repeating. And the last number we're going to plug in is 4. And we get 3.2. So you can see this one is forming this pattern up here. Now if I go ahead and I just plot the entire thing of x squared divided by x plus 1, you can see how it hits all the points that we just graphed. Go projector mode, you can see, you'll be able to see the points a little bit bigger. Take it out of projector mode, it's a little bit clearer. There we go. That looks prettier. Okay, so you can see that the graph goes to the bottom left piece. It's constricted by those asymptotes. It's never going to cross them. And it also is in the upper right piece. That's a pretty common trait for a graph that has x squared, a second degree over a first degree, is it's going to look like this. It's going to look in the bottom left and the upper right. Okay, back over here, let's see how they graphed it. And you can see that graph looks really similar to what we had. So we've got a check your progress problem now. Go ahead and work on this one. Pause the video as long as you need. When you have your answer, come on back and we'll look at the next screen. So our answer this time is graph B. You'll notice this one, if you look at the x again, it's not the bottom left and upper right, it's actually the upper left and the bottom right of that x. This one looks a lot different from what we had. So even though this one is bottom left and upper right, don't automatically pick that just because the first one we did looked like that. Go ahead and work out the problem because not everything is going to come out that way. It's just that something that looks like this is fairly common. All right, we're going to pause this video, end this video, and pick up with example 4 in the next video.